All right, these next few videos are going to focus in on markets. So as we discovered in the last video, or the last lecture, that trade benefits everyone. So if we can negotiate and trade, we can have the winners are going to exceed the losers. And so overall, people trade because it makes them better off. And in this way, we want to formally understand where do people trade. And so a marketplace is going to be a formal place for trade to happen. And so we need to study the market, which we defined earlier as the market is a group of buyers and sellers and the arrangement in which they come together to trade. Okay, so we're going to understand buyers and sellers. And this video focuses on the buyers, and the next video will focus on the sellers. Okay, so this one is focusing on the buyers, or we're going to be focusing on what we call the demand side of the market. Okay, and for this to happen, we usually come up with what we have called a demand schedule. And to think about this, we need to think about what motivates me to buy certain goods. Obviously, I would only buy certain goods if they make me happy. So since I'm a rational agent, I'm going to go to the store and buy things because it makes me happy. And I'm looking to maximize my happiness. So I want to be as happy as possible, and I only have a fixed amount of money. So I have to decide what I'm going to buy and what I have to give up buying in return. And what I do buy is going to maximize my happiness. And we want to understand, is there any way to predict that behavior? Okay, so to think about this, what we're going to look at what we call the marginal benefit. So let's think about pizza. And so I'm a runner, and when I run a lot, I can eat a lot of pizza. So I can pack away a lot of pizza, and I love pizza. So if I'm thinking about pizza, we want to think about, well, what makes me happy, or how do I eat pizza? Okay, so when we're eating pizza, what's always the best piece of pizza? Well, if we're thinking about it, if we're really hungry, that first piece of pizza is always the best. So if I had to put a price on how much I'd be willing to pay for a slice of pizza, that first slice is always going to be the slice that I pay the most for because it makes me the most happy, right? It's the best slice of pizza. So overall, if we're looking at slices, the slice of pizza, and the price, my willingness to pay, right? So that first slice of pizza is the best one. I'd be willing to pay the most money for that first slice of pizza. So if, if somebody was offering it to me and I was starving, I would pay the most amount of money for that one slice. As I said, how much do you want? And they could name a price, and I said, okay, I'll pay that or I won't pay that. Well, if I'm really hungry, for that first slice of pizza, let's say that I would be willing to pay $10. Okay, so overall, I'd be willing to pay $10 for that first slice of pizza. If I'm willing to pay $10 for that, that's really putting a price tag on how happy it makes me, right? Because if I'm willing to pay $10, I'm willing to get $10 of happiness out of that slice of pizza. If it would cost me $12, right, I wouldn't buy it because it's not bringing me that $12 of happiness. I could spend that $12 somewhere else and it would make me happier. So this willingness to pay is also what we call the marginal benefit. It's telling me how much benefit does each marginal slice of pizza give me. We'll call it MB for marginal benefit. Let me zoom in. Sorry about that. Okay, so we have willingness to pay or marginal benefit. If you ask me how much are you willing to pay for that slice, and I say $10, that's saying that it gives me about $10 of happiness. Okay, how about that second slice? So I eat that first slice, so now we're on to the second slice. So we're thinking at the margin. So for slice 2, well, that second slice of pizza, the second slice of pizza is also very good. it's not as good as the first one, right? The first slice of pizza always tastes the best. So if I had to put a price tag on how much I'm willing to pay or how much happiness that second slice of pizza gets me, well, it's not going to be $10. So maybe we'll say it's $8. Okay, so if the price is $8, I'd buy a second slice of pizza. Okay, and then we just continue this on. So for the third slice of pizza, yeah, the third slice is good too. It's not as good as the first, not as good as the second. So I'd be willing to pay $6 for that third slice. For the fourth slice, it's not as good. It's definitely not as good as the first, not as good as the second, not as good as the third. And so maybe $4. For that fifth slice, $2. The sixth slice, I'm indifferent. If it was just sitting there and he offered it to me, I would probably eat it, but I'm not going to pay any money for it. I would be fine with just 5 slices. So we'll say it brings me $0 of happiness, or I'd be willing to pay $0 for it. And then if I ate that sixth slice and you made me eat a seventh slice, yeah, I might throw up. And for me to do that, you'd actually have to pay me. So it brings me negative benefit or negative happiness. I don't like throwing up. And so for me, I would be willing to pay minus $2 for that seventh slice. Or to make me eat that seventh slice, you would have to pay me $2 for it. Okay, so if we're looking at willingness to pay our marginal benefit, this is telling us that as we eat more and more of something, the marginal benefit decreases, right? And so we can think about this like you probably shouldn't know about alcohol, but alcohol follows this very well, right? Alcohol is very good up until a certain point, and then afterwards it's no good, okay? And so when we think about this, this is kind of how we behave for any goods. So let's just say, well, what happens for any price of pizza? So if pizza costs $10, how many slices would I eat? Well, if a slice of pizza costs me $10, I get $10 of benefit from that first slice, so I would buy 1 slice. The second slice, it only brings me $8 of benefit, and if I had to pay $10 for it, why would I pay $10 to only get $8 of happiness? Right? So I wouldn't buy the second, third, fourth, fifth, sixth, or seventh slice. I would only buy 1 slice of pizza. If the price is $8, I pay $8 to get $10 of happiness from that first slice. So that sounds like a good deal, right? I'm getting $10 of happiness, and I'm only have to pay $8 for it. For the second slice, it cost me $8, and I'm getting $8 of happiness, so yeah, I'll buy it. For the third slice, I'm only getting $6 of happiness, but I have to pay $8 for it, so it's not a good deal, and so forth. So if the price of pizza were $8, I would only buy 1, 2 slices. If the price of pizza were $6, I would buy 1, 2, 3 slices, and so forth. So we're going to keep on consuming until the marginal benefit equals the marginal cost, or the slice per pizza. Okay? So if we go to, Paul Revere's and buy a slice of pizza. We go there for lunch, and let's just say it costs $2 per slice of pizza. So I go to Paul Revere's, I get $10 of happiness from 1 slice, so I pay $2 for it. That's a great deal. The second one, I pay $2 and get $8 of happiness, so great deal. $2 to get $6 of happiness. Cost me $2 more to get $4 of happiness. And then for the fifth slice, I pay $2 to get $2 of happiness. So if pizza costs $2 per slice, I would buy 1, 2, 3, 4, 5 slices. Okay, so overall, what we're looking at is the slice and the willingness to pay. Or another way to put this is, what happens if this were the price? This is telling me how many I would buy at that price. Okay? So another way to think about this, let's make a graph out of this first. So we're going to put quantity, so the number of slices on the x-axis versus my marginal benefit on the y-axis. And so we'll call it 1, 2, 3, 4, 5, 6. So 10, 8, 6, 4, 2. Okay, so if I graph these dots and then I connect them, this is telling me my willingness to pay or my marginal benefit. Another way to think about this is, what happens if this were the price? So this is the price, and we denote price P. Well, this is telling me at any given price how much I would buy. So this would be what we call quantity demanded. Okay? Or Q small d. Okay, so again, if the price were $8, I would buy 2 slices of pizza. Or my quantity demanded at price $8 would be 2. So not only is this showing me how many slices I would buy versus the marginal benefit, this is telling me at any given price how much I will buy. So again, our quantity demanded is this dot. Another quantity demanded is this dot. At price $6, my quantity demanded is 3. At price $4, my quantity demanded is 4, and so forth. When we connect these dots, it gives us this downward sloping line, which we call the demand curve. And we denote that big D. So our demand is going to be the total list, how much I will buy at any given price. So you tell me any price for a slice of pizza, and the demand curve tells me how many slices of pizza I'm going to have. So if I have this, and then I ask this of somebody else, and somebody else, and somebody else, and we add it up. So if I buy 1 slice of pizza at price $10, and somebody else will buy 2 slices of pizza at $10, then together we've bought 1 plus 2, which is 3 slices of pizza. So overall, we can aggregate this up over all individuals and get what we call a market demand. So at the price, how much will all individuals demand? Okay? So our demand curve is a very powerful tool. It's telling us how much quantity demanded will be at any given price. And what we notice is that we have this downward sloping demand curve. So as price increases, quantity demanded decreases. Okay, and that's very important. Or another way to put it, as the price goes down, we're going to buy more. Okay, so when things are on sale, you tend to buy more of things. Okay, and that brings us to a very important lesson, which we call the law of demand. And the law of demand states that as price increases, and then I'm going to put in parentheses here, decreases, quantity demanded decreases, and then in parentheses, increases. So as price increases, quantity demanded decreases. As price decreases, quantity demanded increases. Okay, so we have an inverse relationship between price and quantity demanded, right? And this is pretty simple. If things are really, really cheap, you buy a lot of it. When things are really expensive, you buy fewer of it. Okay, and the best example of the law of demand that I can think of is my grandmother. And so my grandmother had 2 cats, Bootsy and Fluffy. And I swear this is 100% true story. So my grandmother had 2 cats, Bootsy and Fluffy. And every day they would eat 1 can of tuna. So each cat would have half a can of tuna in the morning, half a can of tuna in the evening. So, so they would each have a can of tuna a day. So my grandmother always had to have tuna. And in fact, she would only buy 1 kind of tuna. It was chicken of the sea, and it had to be in the water, not in the oil. And so that's the only kind of tuna that she would buy. And she hated paying full price for tuna. So my grandmother hated paying full price for tuna. So what she would do is she would always look in the ads to see when it would go on sale. So the shopping center that we had, or the grocery store that we had, was called County Market in Montana. And so when it would happen, I was like in elementary school. So she would call me up, and I used to go over there on the weekends. And so we do what we'd call a tuna run. So when tuna would go on sale, she would cut out all the coupons, and she would call her neighbors and say, hey, give me the Sunday paper because I want the ads for County Market, so for the tuna. And so she would cut out all the coupons. And then what we would do is we'd drive into town, and there'd usually be a limit, like buy 2 boxes or 2 cases of tuna per individual per coupon, right, or per session. So she could only get 2 cases of tuna, which is what, 24 cans or 48 cans. And then, but what she could do is she could also give a coupon to me, and I could buy that same amount of tuna for the same price. So we would go into the store, and we'd have to go in individually because we couldn't be a family, right? Because the coupons only work per individual, not per family. So we had to go in and act like we didn't know each other. So we go in and pick up the tuna, and then we go through different checkout lines with our maximum amount of tuna that we could have. And then what we do, so we'd go outside, and then we would get in the car and drive across town to the other county market. So we'd go to county market again and do the exact same thing at the other county market. And then we would usually stop for lunch. And my grandmother, she loved to cook. And so she really knew county market very well. And she knew when the clerks would change over. So she would say, okay, it's 2 o'clock, so we can go back to the first county market on the way back home and pick up more tuna because it's new clerks that are checking you out, so nobody would recognize us. So overall, if there was 2 of us, right, and sometimes my grandfather would go with us as well, and there'd be 3 of us doing the same process, and we'd hit the first county market, the second county market, and then go back to the first. And this would only happen when tuna was on sale. So for my grandmother, if price was regular price, quantity demanded was 0. If price was on sale, price was lower than the regular price, quantity demanded was really big for tuna. Okay, and so that's the law of demand. Then the last thing that we want to discuss is, or there's 2 more things. We want to understand how much happiness do I get overall, and so how much happiness do we get overall? And then lastly, we want to understand shifts in demand. So if we're looking at happiness overall, let's say that I pay $2 for a slice of pizza. Okay? So we said that the first time, if price was $2, so here's the price, $2, I would buy 5 slices of pizza. So how happy does that 5 slices of pizza get me? Well, for slice 1, I paid $10. Okay, and I paid $2, but I get $10 of happiness. So for the first slice, I got $8 of net happiness, right? $10 of happiness, but it cost me 2. So overall, I'm $8 better off by eating 1 slice of pizza when I pay a price $2. For the second slice, I get $8 of happiness. So we'll call this 8. For the second slice, I get $8 of happiness, and it cost me $2. So I'm better off $6 for buying that second slice. For the third slice, I get $6 of happiness, and it cost me $2. So overall, I'm better off $4 after eating the third slice. For the fourth slice, I get $4 of happiness. It cost me $2, so I have $2 of net happiness, or I'm better off by $2. And then for that fifth slice, it cost me $2, and I get $2, so I get $0 of net happiness. So overall, by buying 5 slices of pizza, I got $10 of happiness plus $8 plus $6 plus $4 plus $2. So I got 10 plus 8 plus 6 plus 4 plus 2. That's 10, 20, 30. So I got $30 of total happiness, and it cost me 2, 4, 6, 8, 10. So overall, I got $30 of happiness, and I paid $10. So I'm $20 happier off, or better off overall after eating 5 slices of pizza. Or 20 would be 8 plus 6 plus 4 plus 2 plus 0. Okay, so we can count up here and then subtract up the cost, or we can just find the net happiness at each one and then add them up. So 10 plus 8 plus 6 plus 4 plus 2 is 30, plus 2, 4, 6, 8, 10 is 10. So 30 minus 10 is 20, which is equal to 8 plus 6 plus 4 plus 2 plus 0. Okay? And what we call that is, right, it's like if you go to the store and you're willing to pay $30 for something and it's on sale, right? You go, okay, so I'm willing to buy a TV, let's say for $300, right? But it's on sale for $100. Score, I got a $100 TV and I was going to go in paying $300 for it. So that means that I have $200 left over in my pocket over which I would have paid. So I have $200 to go spend elsewhere on other items that bring me happiness. Okay? So if we fill in the area, this area is going to bring me my net happiness after eating 5 slices of pizza, and I paid for them. Okay? We call this consumer surplus. Or what we'll call CS. So consumer surplus is going to be the area under your demand curve, but above the price across all the quantities that we're going to buy. Okay, so at price $2, I buy 5. So I fill in the area under the demand curve across all quantities, and I find the area of this triangle. And the area of that triangle would be 20. Okay, so I said it has a base of 5, height of 10 minus 2, which is 8. So 5 times 8, which is 40, divided by 2 is 20. So the area of this triangle is 20, which is what I said my net happiness is after the transaction. So after eating all the pieces that I would eat, I would feel $20 better off after I've eaten the pizza. Okay, and we call that consumer surplus. Okay, so we're going to come back to that. That's a measure of allocative efficiency because it tells me at the price I can measure how happy I am. So allocative efficiency is measuring production maximizes happiness. Well, now I have a measure of happiness here. Okay, so this is going to be allocative efficiency is my consumer surplus. All right, last thing. And this segment's going to take about 5 to 10 minutes, so just bear with me here. So I'm going to erase this, and we're just going to start off with a very simple demand curve. Okay. And in fact, I'm going to have a little cheat sheet off to the side. Okay. So this will be my cheat sheet, and this is going to be my working space for now. All right. The next thing we're going to look at is, well, what happens if other conditions change? So my demand curve, where I have quantity on the x-axis, price on the y-axis, and I have a demand curve that's downward sloping. Okay, so this is telling me at any given price how much I'm willing to buy. But things might change. So we sit there and we look at it, well, you know, other things might change. What happens if I find out I really like a food? Well, if I really like a food, I might start buying more of it, right? But the price is holding constant. So here, we're going to be looking at what happens if something else changes other than price or quantity. So we're looking at what happens if we change a third variable. So we have a two-variable graph, and a change in the third variable is going to shift the curve. Okay, so let's use sushi as an example. I'm a big, big sushi fan. It's probably my favorite food. So here's my demand for sushi. Now let's just say I get a raise. So I make $300,000 a year, right? Or $300,000 more a year. So I'm rich. If I'm really rich, if the price of sushi is really high, instead of buying this much, I'll probably buy more of it. If the price is lower, instead of buying this much, I'll probably buy more of it. So at this price, I'll buy out here. At a really low price, this is how much I would have bought under my old income, but now that I make more, I'll buy more at that price, so I shift over. So what happens is for an increase in income for me, my demand for sushi shifts to the right. So I use prime, so I went from D to D prime, and that's going to be my shift in demand. Okay, so my demand curve shifted to the right, or my demand for sushi shifted to the right when income increased. Okay, just for clarification, an increase in demand is going to be the shift of the curve, right? So this is an increase in demand. It shifts to the right. A decrease would be a shift to the left. An increase in quantity demanded would be if I move from this point on the demand curve to this point on the demand curve. So by lowering price increases quantity demanded. So an increase in quantity demanded is a movement along the curve. An increase in demand is a movement of the whole curve. Okay? So what we want to look at is what are some other factors that are going to affect demand other than price? Okay, and this one was using income. Okay, so here we have increase in, okay, well this was income. If we have an increase in income, for me, my demand for sushi went up. There could be cases, however, that my income goes up, but I would buy less of a good. So a good example of that might be, so we have demand, quantity, and price. Let's say top ramen. So if you're really poor, ramen is very appealing. If you don't like ramen and you make more money, you might buy steak instead of ramen. So as income goes up, you might actually buy less ramen. So my demand for ramen would fall as my income goes up, but my demand for sushi would increase as my income went up. So sushi for me is called the normal good. Ramen for me is what we call an inferior good. Okay? So here, if it's a normal good, we use a different color, green. So we have an increase in income. If it's a normal good, my demand is going to increase. If it's an inferior good, inferior, like ramen for me. So we're not saying anything about the quality here. That's just the terminology that we use. So here's quantity, price. My demand will decrease if my income increases. Okay? So a change in income is going to change my buying behavior. And depending on if it's a normal good or an inferior good, then my demand may increase or it may decrease. Okay. Now let's think about, let's use fruit. So my wife likes fruit. She's indifferent. She has to have fruit with lunch, and she usually eats apples or oranges. So, and she's indifferent between the two. She likes just as much well off. She just needs fruit with her lunch. So if we're thinking about fruit, what happens if the price of oranges increases? Okay. So if the price of oranges increases, that means that she'll buy less oranges, right? So here's oranges. Here's her demand for oranges, quantity and price. So P goes up to P prime. Price of oranges increases. Here's QD. Here's QD prime. Quantity demanded fell. So she's buying less oranges because oranges are more expensive. So what do you think would happen to her behavior for buying apples? So here's her demand curve for apples. If she's buying less oranges, that means that she's going to have to buy more apples to offset the decrease in oranges so she can still have fruit for lunch. So for her, her demand for apples is going to increase. So notice how she was indifferent between eating apples or oranges. She's substituting apples for oranges when the price of oranges goes up. Okay, so if we have an increase in the price of a substitute, demand is going to increase. So increase in price of substitute is going to lead into an increase in demand. Okay? Now let's think about peanut butter and jelly. So I'm not a big fan of peanut butter, but I like it with jelly only. So I'll eat peanut butter and jelly sandwiches, but I usually don't eat peanut butter just by itself. So for me, I have to eat peanut butter with jelly. Okay, so here's my demand curve for jelly. And I want to understand how does my demand for peanut butter change when the price of jelly changes. So here's my demand curve for jelly, my demand for peanut butter. Now let's say that the price of jelly increases. So I buy less jelly because jelly is more expensive. And if I only eat peanut butter with jelly, since I'm buying less jelly, that tells me that it doesn't matter what happens to the price of peanut butter, that I'm just going to buy less peanut butter overall because I have less jelly to eat with it. So for me, when the price of jelly goes up, my demand for peanut butter falls. So if we have an increase in the price of what we call complements, because for me, peanut butter and jelly are complements, while oranges and apples are substitutes. Okay, so an increase in the price of a complement will lead to a decrease in demand. Okay, these ones are the hardest ones. So an increase in income, we have two outcomes: increase in the price of a substitute, increase in the price of a complement. Here's what happens to demand. Okay, the last ones are a little bit easier. Okay, so again, this is ceteris paribus, or it's Latin ceteris paribus. it means holding all else constant. So holding all else constant, if income increases, my demand for sushi will increase. Holding all else constant, including price, if my income goes up, my demand for ramen will go down. Okay, so forth. Okay, now, besides the price of a substitute and a complement in income, there's a few other things. So well, what about tastes and preferences? So an increase in my taste for a good, or my preference for a good, will increase how much I buy of it. So I recently ate starfruit for the first time, and I found out that I really like it. So I found myself going to the store and buying starfruit more often than I did before because I found a taste for it. So for an increase in taste and preferences, we're going to see demand increase. Next one is going to be population. So we're looking at market demand here, okay? And so if we have an inflow of 1 billion people into the US, what's going to happen to the demand for pizza? Well, here's what it looks like with 300,000. But now we get 1 billion more people in the US, so there's 1 billion more people that want pizza as well. So the demand for pizza would increase as population increases. Okay, and then the last one, and this one's important, is expected future price. So what happens if I told you that the price of gasoline is going to be very, very expensive starting tomorrow? So if you were looking to fill out, would you rather fill up today or tomorrow if gas is going to be very expensive tomorrow? Well, if gas is going to be expensive tomorrow, it makes sense that you would buy gas today. So if we have an increase in expected future price, what we see is an increase in demand today. We expect gas to be expensive tomorrow, and we're going to buy more gas today as a result. Okay? So change in income, change of complement or substitutable goods, taste and preference, population, and expected future price are going to be what shifts demand. Okay, so these things are going to sum up everything that other factors that would change our buying behaviors other than price. And that's our lecture on demand.